So we directly move on with the next presentation. It's being held by Román Orús. Román Orús is the CSO of Multiverse Computing, and he is presenting the view of multiverse computing when it comes to quantum software for today's industry. I'll directly hand over to you, Román, and we look forward to your presentation.
Excellent. Thanks a lot. Let me share my screen. That's it. Well, thanks a lot for the opportunity to give this talk. It's really a pleasure to have the opportunity to be talking to you about what we are doing at Multiverse Computing, and also about quantum computing. I think that these are very exciting times for everything that is going on in the quantum ecosystem. We are starting to see the first applications of quantum computing in industry, and something coming also from academia. This is also something extremely exciting. Okay, so let's talk about Multiverse and how we are approaching these things. First of all, let me share some details about Multiverse. Okay, we are, as of today, the largest company in the European Union doing quantum software in terms of capitalization. Headquarters in San Sebastian in Spain, but we also have offices in Toronto, Paris and Munich. We are around 50 people right now. This number fluctuates depending on the day. Around 40% PhD people, 30% women, a lot of international talent. Actually, we have around 15 nationalities here at Multiverse. We speak around 20 different human languages. We are making the transition from a project company towards a product company this year. Okay, we have some algorithms that are outperforming the standards of the market in several cases. Originally, we started operating in finance, but we are starting to diversify our operations. Also, we are starting to work also in energy applications, in manufacturing, in logistics, in space, in life, okay, and several other verticals. We have been growing very fast. We actually started in 2019, and the last year we already closed contracts for a value of 6.8 million. So it's really possible to make money with quantum computing as it is today. We're just proving it. And well, you know, we closed a seed round of 10 million last year. We also got granted 12.5 million from the European Innovation Council. I think that was the largest investment from the European Union in a software company. We have also a very intensive patent program, filed 22 patents last year. We are projecting around between 22 and 24 probably for this year. And well, we have appeared in many places. Now, I don't want to bore you too much, just to show you that, well, you know, we are also in the Tech Council of McKinsey. We have appeared in reports of the Boston Consulting Group and reports by IBM. We are also part of the European Industry Consortium. Okay, we are the treasurers there, and we are also inside of that. We have been appearing in The Economist, in Sifted, in Forbes, in several places, actually a couple of times. So, you know, quantum computing in industry is actually making some noise internationally. Now, why is this the case? How are we seeing the game from Multiverse? What is our vision? For us, it's very important to realize that in order to bring quantum computing to industry, one needs to think in terms of the actual end user. Okay, it's not just about thinking about quantum computing. We cannot do quantum software for quantum physicists, okay, because the end user at the other side is not a quantum physicist or a quantum engineer. Okay, they probably have no clue about quantum mechanics. So our vision is this one. First of all, we think it's wrong to ask when are quantum computers going to be fully developed, okay? Because some people say, well, you know, this is still at a very early stage, and then you cannot do actually anything that is useful with quantum computers. Well, we think that we strongly disagree with this point of view. We believe that the correct question is what you have here on the right-hand side, okay? The correct question in terms of extracting value and industry is how can we extract industrial value of the current quantum computers. Okay, so we have these processors right now that they are noisy, they are small. You know, we like to have many more qubits and have them error correct and so on, but unfortunately we don't have that. We have these first prototypes. So, okay, can we use this for something that is useful? Okay, so beyond just an academic problem, let's say. And the answer to that, I advance you, is yes. But then the point is to ask the right question. What can we do with the machines that we have today? Okay, of course, with the machines that we have in, I don't know, 50 years, we're going to be able to do everything and lots of things. But the hard question is, what can we do with what we have now? Okay. The second important question, if you want to target the industry, is what you have here. Is that, well, as I was saying, you have to understand that the final user is not a quantum engineer. Okay, so you have to provide the solution in an easy way. It has to be easy for the people, okay, to use a quantum computer. They don't need to know quantum mechanics. They don't need to know about Schrodinger equation or anything like that. No, I mean, they just need something that works. Okay, it will be like, you know, buying a radio and asking the end user that they need to know about microelectronics. Okay, or I don't know, buying a car and asking the people to know about the actual complex mechanical systems that they have and how they integrate with the electronics and so on. No, I mean, you buy a car and you just want to drive. No, so this is the point of view that one has to take if you want to target the industry, okay? And it's really an important transition, because when you come from academia and so on, you are typically here on the left-hand side. But if you want to go to the market and actually to industry, you must be able to do the transition to the right-hand side. Okay, if you stay on the left-hand side, then it's just wrong. Okay, it doesn't work. Now let me show you in a couple of minutes video an example of how we are doing this at Multiverse for one specific application, which is optimization of portfolios.
Multiverse computing singularity makes quantum computing really easy for the inexperienced user. Singularity allows you to unleash the power of quantum computing directly with a click and assuming no previous quantum knowledge at all. For this, the team at Multiverse have connected quantum computers, working on the cloud as a backend, to really simple and intuitive front ends. Our vision is to implement quantum computing directly via these tools, so that it can become a part of the production line of any financial institution. Singularity allows you to connect powerful quantum computing directly to your favorite spreadsheet. Let's see how our quantum powerful portfolio optimization algorithm works. Spreadsheets like this are used by analysts to deal with financial data and obtain the products that are sold to clients. After installing our plugin, we just need to specify the relevant input data, like returns and volatilities of the assets, and other parameters such as total investment and investment bands. After clicking Start Optimization, Singularity takes care of designing the optimization problem, sending it to the quantum computer on the cloud, getting the results back, and displaying them in a user-friendly way. As you can see, optimizing the full S&P 500 takes just a few minutes with Singularity, whereas it is a never-ending task with other state-of-the-art algorithms. Moreover, the obtained portfolio also provides higher returns than standard simplified solvers, which gives suboptimal solutions. And it's as easy as just one click in your spreadsheet. Singularity is quantum powerful and as easy as pie.
Good. So you see, this is an example for one specific application. This was optimization of portfolios, of investment portfolios using quantum computers. Oops, sorry about that. But you can see the idea of what I was saying. You use this specific application. We have a plugin that, it just deploys into a spreadsheet. Okay, it installs there, and then you just click in the plugin, load the data, click the button, and then the magic happens. And then all the complicated thing is behind. Of course, there is here a very complicated interface that connects to the quantum computer in the cloud, and gets the results, builds the actual algorithm, does the optimization, and so on and so forth. But the end user doesn't see anything of that. The end user, the only thing that they are seeing is a plugin that they connect, they load the data, and it works. Okay, this is the approach that one has to take if you want to take quantum computing to the market and also to the masses, because we have to bring it to everybody, not just to the quantum engineers. Now, in which verticals can one enter in quantum computing? Well, actually, as you know, in many of them, finance is one of the most prominent ones. Okay, this is also how we started. We have several use cases going on in finance, not just portfolio optimization, but also energy. Actually, we are working on several projects on energy right now. Energy is kind of, in general. So it's one of those fields where one is finding more use cases also about quantum computing right now on top of finance. Okay, then of course advanced industry, pharma, telecom, media and technology, public and social sector, healthcare, of course, transport, mobility, insurance, and I could continue mentioning different verticals. Okay, and in all of them actually one can find use cases for quantum computing. We are entering essentially in all of them, and actually in some other few that we are not showing here. For instance, these are some people that with whom we have been working already. You can see here, you can recognize here several banks, BBVA, CaixaBank, Bankia, even a tax agency here from Spain, but also German manufacturers such as ZF, the Zeppelin Foundation, okay, or Bosch, okay, on topics about logistics, but also energy companies such as Repsol, the Bank of Canada, other banks such as CACIB, past chemistry companies, even satellite providers such as Hispasat. So, the field is really diversifying. Now, from our perspective, one has to work on problems that you can actually solve on an actual quantum computer. We think that the world is divided into 4 pieces in terms of algorithms: optimization, quantum machine learning, pricing. This is from the finance side, but this means stochastic problems and also simulation. Okay. We believe that for optimization and quantum machine learning, quantum computers as they are today can start offering industrial value. Okay, and we are actually observing this in the products and in everything that we are building. And then for pricing, essentially for stochastic simulations and for simulation of physical systems and of complex systems, we believe that quantum computers will start offering value, industrial value, at a more advanced stage. Okay, we are still not there, but in those cases you can also use quantum-inspired technologies. This is what we do at Multiverse. We use 2 types of technology. On the one hand, we use quantum computing. We are quantum agnostic. We try to be able to use all possible quantum hardware providers, all possible quantum processors that are out there. On the other hand, we also use quantum-inspired technologies, in particular tensor networks. This allows us to, be able to offer value more in the short term for those problems for which quantum computers are still not ready. This is not just us saying that. Gartner also did at some point an analysis, and here you can see one of those magic quadrants with many applications of a quantum computer, okay, where in the horizontal axis you have the time to market, in the vertical axis you have the impact, okay, and you can see that some applications of a quantum computer are going to come at a later stage, but some other are going to come sooner. You can identify essentially machine learning and optimization, which in my humble opinion should be much higher in this graph because it's very relevant, as 2 of the applications that are going to come sooner. Okay, we are seeing that we are starting to be able to solve problems, real problems of real size, okay, and which have already industrial value in the case of optimization, and also in the case of quantum machine learning. Okay, we are starting to see quantum algorithms outperforming some of the best AI classical algorithms in some, say, pattern recognition system, anomaly detection, and so on. We are just starting to see that. Now, about quantum-inspired computing, I will not go into too much detail. We've been working, as I was saying, in several problems, for instance, in portfolio optimization with several banks. Here is the first example where we saw that quantum computers can start outperforming classical solutions. We were obtaining results with the D-Wave quantum computer that were actually much better than the standard product that was being offered by essentially any Spanish bank during 2019. Okay, that was very significant. D-Wave was also very happy. They even did a highlight about that you can take a look in PDF. And right now the algorithm is much more powerful. In fact, we are able to optimize a portfolio with all the companies of the SP 500 index in the US, which are, the 500 biggest companies in the US stock market. That's an amazingly complex problem, okay? One of astronomical size, one of those problems that are highly intractable. And we are actually able to solve that, and we have integrated that in our solution that we call Singularity. Now, I will not bore you with the types of partners that we have, but essentially we are working with everybody that makes sense in quantum hardware, and there are actually some people that are also missing here. And this allows us to, be able to also adapt the actual problem to the quantum hardware. Okay. Now, thanks a lot for your attention. And now I guess it's time for questions.
Thanks for the very, very interesting and very, very comprehensive talk. So the first question could you give us some experiences across, when you look on the European Union and uptake of quantum computing in the European Union, quantum technologies, some experience, some insights when it comes to comparing industries and experiences within industries within different member states of the European Union?
Yeah, I mean, from our experience, we see that in terms of verticals, so the financial industry is betting very strongly on quantum computing. I think that essentially, I would say that the most important banks in the European Union already are building their own quantum technology teams, and they are running different pilot projects already to be able to identify which type of problems they have and so on that can be interesting for this technology. And as I was saying, the second vertical that we are seeing with more activity is energy. Actually, energy providers, we've been talking already with several ones in different countries in Europe, actually, and they are as excited as the banks, let's say. I would say that these are the two main verticals right now where we are seeing more activity. Okay. Apart from that, in Europe, we are seeing a lot of activity also in hardware. Let's say there are several things going on with several proposals in different countries in Europe, also with different types of technology, actually, and I think that's very interesting to see what's going to happen in the future.
Maybe a second question, you already touched a bit in the end, as you described the activities when it comes to hardware. What is your advice to ecosystems from private sector, both supply side and demand side, one could say, and also to policymakers when it comes to how to advance and how to proceed in European quantum ecosystems?
Yeah, that's a good question. So of course, it's important to make important bets and investments in quantum technology companies. There is always the danger in Europe that the US or Americans, let's say, or other regions are going to take over, and this is a danger. I think that we cannot be left behind. So the bet has to be very clear. Okay. There must be important investments in quantum hardware, and the quantum hardware companies, they must grow and in order to be able to compete with the ones that are popping out in the US. And the same for the quantum software companies. So because eventually, there is this story between software and hardware, and it looks like hardware is more variable, but eventually software will take cover, and this is exactly what happened in classical computing also. And one must realize that in Europe, if we don't take this very seriously, we are gonna lose this race against the Americans. Okay, and this is not something that is new. I mean, it has happened in other industries already, and we really need to make a strong policy here to have a European quantum computer to be able to compete, and also to have some important software companies that can compete.
Yeah, that was a very strong concluding statement, I think. Thanks a lot for your very interesting presentation and your answering the questions very comprehensively and with strong, convincing arguments. Thanks a lot for your presentation.
Thank you.